Hello, YouTube. This is Umozo3. In the previous lesson, we introduced something called a sorting algorithm, and we basically learned about an approach to sort a list or a tuple, for example. Okay, and so what we want to do is we want to go ahead and review bubble sort. Okay, and bubble sort is a very inefficient but easy to understand algorithm for sorting a collection of sortable elements. Okay, and so when we're talking about sortable elements, we might be talking about integers or floats or perhaps strings. Remember, we've talked about previously how strings can be compared lexicographically. They can be compared according to how they appear in the dictionary. But what we're going to talk about in this video is that we can actually sort any objects that are considered sortable. And then when we were talking about object-oriented programming in lessons like 35 and 36 and 37, we talked about magic methods. We talked about dunders, okay? And so dunders basically enable us to specify what is meant when we try a numerical or a Boolean operation on two objects, right? So what does it mean to say that one person is equal to another person? What does it mean to multiply a water bottle by another water bottle, right? But those kinds of operations can be totally defined at your own discretion according to what makes sense within the context of your program. But anyway, in this video, I wanted to go ahead and review bubble sort a little bit. But I want to talk more generally about sortable objects, okay? And so we're going to be reviewing a little bit of object-oriented programming. I created a class here, and so I want to basically refamiliarize you with some of these techniques that we have for sorting objects, for making sortable objects, okay? Because we want our examples to not just be for integers and floats, right? We already know that 5 is bigger than 1, but what if we want to have more of an object-oriented perspective, right? What if we were talking about sorting people, or sorting cars, or sorting dogs, or sorting potatoes, okay? And so you can figure out how you would do that, and you can figure out what your implementation would be for something like that. What I wanted to do first is I want to talk about Lambda functions without inputs, okay? So for about 25 or 30 lessons, we've already learned about Lambda functions. We've already known about Lambda functions. And then we could say something like my function 1 equals lambda a, and then you could say a mod 2 equals 0. Okay, so this is an example of a Boolean function. And it returns true if its input is even and false otherwise, right? Okay, and then we said that we could also have a function of 2 inputs, right? And so you could say lambda bc, and then you could say basically b plus 3 times c, for example. So that would be an example of a function with multiple inputs, right? You could have 5 inputs and choose to only use 3 of them, right? And so you could have said something like that, and it wouldn't be okay. It just means that e and f don't end up affecting the output of the function, even though they are technically listed as inputs. So hopefully that's clear to you. And then what we also said is that a lambda function could print something. And so what if you said lambda x comma y, and then you just wanted to say print length of x, okay? So basically what would this imply? Well, this implies that y can be anything that it wants to in the whole world because we're not using that input, right? We said that, data types of inputs have to make sense within the context of the function, but this function doesn't even use y. So it doesn't matter if it's a Boolean or a float or a list or anything else. But x has to be an iterable, right? If we say length of x, that implies that x is either a string, list, tuple, set, or dictionary, okay? And so what you would do is you would basically, this is an example of a lambda function that doesn't return anything. It prints something. So what if you had said something like print my function 3 of 5 and 2, okay? So that's an example of a function that accepts 2 inputs, but what we're trying to drive home here is that this function doesn't return anything. So if you try printing the results of that function, it would basically, okay, well, 5 is not an iterable, right? So what if we said 5? What if we said a string that's 1 element long, 1 character long, right? So now if you go ahead and run it, it would be able to print 1, right? It would print the length of that string, but then it would say none, right? Remember we talked about previously how none is like the data type associated with no data type, right? This function doesn't really return anything, right? But when we try printing it, it makes a call to the function. So it executes the function's context, but it also tries printing the output of the function on the console. And so the answer to that, the output of the function is just none. Okay, it doesn't return anything, it just prints something. And we've already seen examples of that with regular functions, right? If you said define f of x and you would say print x, you wouldn't set f of x equal to something, you would just call f of x. So hopefully that's clear to you. But this would be an example of a lambda function that doesn't return anything, it just prints something, right? You wouldn't really want to see that none there, right? That's not very interesting. You would just call my function of 5 and 2, and then you would get that 1 here. And then this all this other stuff is an example. I was playing around with that. We'll talk about that in a second. Okay, and then we also talked about garbage collection. So remember, we used the DEL keyword for garbage collection. Okay, and so that's if you no longer want a particular variable to hold on to a value that it was once holding on to, right? And so what if you said something like what if you said x equals, and then you said my function 1 of 10. Right, and so here x is equal to true, right? Because 10 mod 2 is equal to 0. The remainder when you divide 10 by 2 is in fact 0, right? But then what if you said del x, and then what if you said assert x is true, okay? And so typically, remember we said that with an assertion, remember the assertion will continue to run the program. If you say assert and then a Boolean, there will be no issue if the Boolean's true, but if the Boolean's not true, there'll be a runtime error. Okay, so what we would do here is we would say x is not currently assigned to true ... right? That would be the error message that we would print if this Boolean were false, right? If we were throwing a runtime error, what kind of error message would we want to get? And it says a name error, right? And it says x is not currently assigned to true, right? Because we said that we wanted to assert that, right? But it says x is not currently assigned to true. X is not even defined, right? Because we deleted it from memory, right? But then if you delete the delete, right? If you don't do the garbage collection, then it's okay to say sir x is true, and then there's no problem running the code. We also talked about the pass keyword, okay? And remember that the pass does nothing at all. So you can put pass here, you can put pass here, you can say pass, 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 right? You can say for r in range of 6,000 pass, right? And so this would do nothing at all, right? It just reads the word pass and it keeps going. And so remember we said the pass keyword is a pretty nice placeholder, right? It's a good thing to do if you don't want to do anything at all, right? If you wanted to have like an if-else block or something, right? And you wanted to say, okay, if something is true, do something. Otherwise, do something else, right? But you didn't really like have something to put in one of those sections, you can just say pass. But the point is that's an optional keyword. It's sort of like a filler. It's kind of like if you said right? It's like, I was doing pretty well, but you know, it's not exactly like that, but it's sort of like that, right? It doesn't really add a whole lot of substance, but there's nothing illegal about saying it, right? And it says pass is a null operation. When it is executed, nothing happens. It is useful as a placeholder when a statement is required syntactically, but no code needs to be executed. Okay, so define f of arg pass, right? So it's a function that does nothing. Or class C, what if you just said pass? It would just be basically a class that has no methods in it, right? It has no methods or variables in it, but it would just be sort of an empty class. So hopefully that makes sense to you. But I just want to go ahead and talk a little bit more about these sortable objects, right? So we've already talked about bubble sort. So one of the things we can do in this video is we can review bubble sort, okay? And so what we do is we have doc strings here, and this was the function we were looking at in the previous video. And we talked about algorithms, right? So algorithms are approaches that you take to solving pretty simple problems, right? What if you wanted to sort a list? Or what if you wanted to search for an element within a tuple, right? And so would you start at the beginning of the tuple? Or if the tuple were sorted in a particular way, would you try to break it up in chunks, right? Maybe you'd look at the middle of it and then, you know, either look to the left half or the right half from there if it were sorted. But these are examples of different algorithms. And we're going to be talking in total about 3 ways to search, 3 ways to sort a list or tuple, and 2 ways to search for an element within a list or tuple. But anyway, this is one algorithm, and this is an algorithm that we brought up in the previous video where we said define bubble sort of my list. Okay, so it's a function that accepts one input, okay? And so we're gonna have doc strings for it. We had formal documentation in the previous video, but we said this function accepts a list and returns a version of the iterable where the elements are sorted in ascending order. This works for both numeric and lexicographical elements. Okay, and so parameters, well, we have a parameter and input, my list, that would be a list to sort, okay? And so what does it return? Well, it returns a sorted version of the list, right? It accepts my list, and somehow it's going to return my list. But the work that it does in the middle is to sort the elements, right? It's going to mix up the values of the index positions of the elements in such a way that you're going to have the smallest elements at the beginning and the largest elements at the end. So we said in order to do the bubble sort, we have to say for W in range of length of my list -1, and then 0, and then -1, right? So remember the range function, a lot of the times it only accepts one argument. Like we could have said for W in range of 12 or for W in range of 5, right? But range can also accept 3 arguments, right? And so if you accept 3 arguments, what you do is you start at the first argument, okay? And then basically, since the third argument is negative, we're going to be working our way downwards. So we're sort of going to be starting like at the end of the list, and we're going to be working our way to the beginning of the list in units and increments of -1, right? It's going to be looking at the end of the list, and it's going to work its way to the beginning of the list. But it's going to be a nested for loop. So for each of those values of W, we're going to iterate from 0 up to W using another variable called X. So we're going to say for X in range of W. And then it's going to be an if statement. So the if statement is really critical here. It's going to be the comparison. So you could have said if my list of X is greater than my list of X plus 1. So basically, if we're looking at a current element, and then we're also looking at the element to the right of us, the next element over, and we say if my current element is bigger than the next element, well, that means that there's a contradiction, right? That means that I'm not in ascending order, in which case I would want to go ahead and swap the positions of those two elements. So like we said in the previous video, my list of X, comma, my list of X plus 1 equals my list of X plus 1, comma, my list of X. And then you would just go ahead and return the list after you did this sorting operation. Okay, so this is a pretty simple algorithm, right? It's not very hard for you and me to understand. It fits basically in about 5 lines of code from 60 to 63, and then you have one more right here. Okay, but the trade-off is that it's not very efficient. Okay, so we're learning about how this works, but you wouldn't want to just tap a bubble sort into your software engineering work, because this is not a very efficient algorithm. It doesn't do things in a very quick way, especially for large lists or tuples, especially for large collections. But what we want to do is we want to think about how we would go ahead and sort something that was not just integers or doubles. So one of the things you might remember when we were talking about object-oriented programming is that anything can be sortable, right? I think we were talking about point objects, right? Remember when we created a point class in lesson 35 or 36? And we could say, I forget exactly how we defined it, but we were able to come up with a characterization of if we wanted to say that one point was less than another point, okay? And I think we either looked at their X coordinates or their Y coordinates or something like that. But we were allowed to define that. And so what we could do is we could come up with a person class, and we could create person objects, and we could specify to Python what we want it to mean if we say that one person is less than another person. And if that's really critical, because then we can have a sorted list. We can have a sorted collection of person objects, right? And that's a little bit more interesting than just a sorted collection of integers, right? A sorted collection of floating point numbers. You can have a sorted collection of anything in the world as long as you specify what it means for one element to be less than another element. And we're going to do that with a magic method. We do that with a dunder. Let's think about this person class. We have a constructor here. It accepts 2 inputs. Remember, self is not an input. Self indicates that this is a method that applies to an instance, right? This is responsible for creating an instance of the person class. It's called a constructor, and remember, it has 2 underscores and then in it, and then 2 underscores, and you pass in this word called self. And then we pass in 2 parameters here, so n and a. And we're just going to assign the name and age instance variables to n and a for the particular person instance. And remember, we said that if we have 2 underscores before the name of the instance variable, then that means that it's a strongly private instance variable. So that means that other classes or outside of this person class, you're not able to call name and age directly unless there are getter and setter methods. So in lesson 40, when we were getting to the end of our discussion of object-oriented programming, one of the things we talked about is getter and setter methods, or rather setters and properties, maybe they might be called in Python. But basically, since name and age are strongly private instance variables, what we can do is we can come up with functions, right? We can come up with a setter method and a getter method. And basically what this would allow us to do is it would allow us to retrieve the value of a strongly private instance variable. So it would allow us to access the name from outside of the class even though name is a strongly private instance variable. And similarly, we would also be able to change the value of the strongly private instance variable from outside of the class, as long as we have at name.setter. So these are examples of decorators, right? So you would say at property on top of a function that's intended to return the value of a strongly private instance variable, and at name.setter or at age.setter or at instance variable.setter on top of the function that will modify the value of an instance variable that otherwise would have been strongly private, that otherwise would have been inaccessible from outside of the class. So we talked about these type of functions in lesson 40, and so hopefully you're familiar with those. But we have getter and setter methods for one strongly private instance variable for the name, and we can do the same thing for the age, right? So, and then we can have that. So hopefully that's clear to you. And then we have a little toString method, right? So if we try printing an instance of the person class, we say that we want their name and then is, and then their age, right? The string representation of their age, and then years old, right? Because you cannot concatenate a string with an int. So you need to go ahead and convert this int, this age int, to a string, and then you can concatenate it with the rest of these other words. Have birthday, if you call the have birthday function, it doesn't return anything. It's a void instance method that increases the age by 1. It's like if they had a birthday. So here's what we're going to do. Here's what we're going to use to compare to make the person object sortable. Here's what we're going to use in our example of bubble sort for this video. We're going to say that one person is less than some other person that we're comparing to, if the length of my name is the length of the other person's name. So that's how it's defined according to this magic method. This is a dunder. So you need to write DEF and then underscore underscore LT underscore underscore and then of, and then remember you write self here, but self is not an input. Self means that it's an instance method. You only really pass in one input. You pass in other, and you just check to see if my name, if the current name has a length that's less than the other person's name. So hopefully that's clear to you, and that's what our definition is going to be. Because now what we can do is we can sort person objects. We can sort them, right? And then we could just say that one person is bigger than another person if that other person is less than me, right? Because now the less than operation is defined. So we can define one magic method. We can define one dunder in terms of another dunder, right? You know, we can define greater than in terms of less than, and then less than in terms of, you know, something that's clear. And then also get item, I think we'll skip that. We're sort of running out of time to talk about that. But anyway, we're going to create 6 person objects. So we created 6 instances here. So we say u equals person of Tom and 81, right? And it's using this constructor over and over again. So it's using the constructor that accepts 2 inputs. So it accepts 2 inputs here. Okay, and so we pass in basically 2 inputs for these 6 objects, right? And then we're going to basically feed in those 6 objects into a list, right? And we're going to say my people equals, and then UVWXYZ. And then what we do is we say for Z in my people, print of Z. And so that would call the str, would call the string representation of each of the person objects. So say Tom is 81 years old, Stephanie is 33 years old, Kate is 39 years old. But in this video and in the previous video, we've been talking about sorting, okay? And so what if we said bubble sort of my people? And so now what it would do is it would be able to see whether one person is less than another person, right? We can feed in a list of person objects. We can feed a list of objects into our sorting algorithm, right? You know, person objects, this is something a little bit more interesting than just floating point numbers or integers, right? But now this operation is defined. Now we know what it means for one person to be less than another person. We're just looking at the lengths of their names, okay? So now what we're gonna do is when I ran this console output, line 120 had been commented. We weren't doing any bubble sorting. But now what we're going to do is we're going to do some bubble sorting. So instead of first printing Tom is 81 years old and then Stephanie is 33 years old, we're going to want this list to be sorted in such a way that the people with the shortest names are going to appear at the beginning of the list, because we made our person class into a sortable class in such a way where we define a smallest person to be the one with the shortest length. So we're going to go ahead and sort the list, and we want to go ahead and see what happens if we run this executable Python file, right? It says Bo is 66 years old first, right? Now X corresponds to the minimum person object according to how we made this class sortable. So the point is that you can basically define what it means for an object to be sortable, okay? And so you should be applying sortable objects, so not just ints and doubles, to our exploration of bubble sort, insertion sort, and selection sort. So going forward, we're going to use person objects and not just integers. So from UMOS 03, thanks for watching and please subscribe.